Okay, so on this problem, it says Sonia sets off on her hike from the lodge at a bearing of south 80 west. After 3.6 miles, she changes her bearing to south 16 west and continues hiking for 7.2 miles. Find Sonia's distance from the lodge at this point. Round your answer to the nearest hundredth of a mile. So how are we gonna do this? Well, let's come over here. And so notice she's heading west and west. So I'm going to come over here and whenever they give us a bearing, we want to draw a little axis system, right? So I'm going to do that right here. Little axis system. We've got north, south, east, and west. And so, in fact, let me get this W up here out of the way. Okay, so how's Sonia going? She's going south, right? Starts with south, but then 80 to the west. 80 is like almost like she's kind of going that way. 80 degrees to this, almost a full 90. So let's do that. So Sonia's kind of heading off this way. And this right here is 80 degrees. Okay, but then, and she does that for, it says after 3.6 miles. So she does this for 3.6 miles. But then she turns, changes her mind, changes her direction. She goes south 16 west. So at this new point right here, she's going to do a new thing. So every time they give us a bearing, we have to draw a new axis system with the north, south, east, and west there, and do what they say. What they say? Start with south, but then go 16 to the west. So start with south again, but just a little bit west of that. This is 16 degrees to the west. So that's where she's headed now. So now she's headed kind of like this, and it's twice as far, notice. It's 7.2 miles. So I made that line look like it's roughly twice as far. She stops right here. And this angle here from there to there is 16 degrees. That's what they said, south, but 16 to the west. She stops there and says, find Sonia's distance from the lodge at this point. In other words, how far is Sonia from the lodge? How far from here to there? Here's the lodge where she originally started. Oops, not the Lord, but the lodge. And this is where Sonia ends up. They want to know X, that distance, right? See how I drew that situation? So again, she started at the lodge, from the lodge, south 80 to the west, goes for 3.6 miles. Then she changes, goes south 16 to the west for 7.2 miles, twice as far. At this point, how far is she from the lodge? Okay, got a triangle. No big surprise there. Is it a right triangle? No, clearly not. So I can't use SOHCAHTOA. I don't know if you're understanding that. If it was, we can only use SOHCAHTOA, meaning like sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and all that stuff. You can only use SOHCAHTOA when you have right triangles, right? Because it mentions hypotenuse. You only have a hypotenuse when you have a right triangle, because the hypotenuse is the side opposite the right angle. So this triangle is not a right triangle, is it? It doesn't have a right angle. So I can't use SOHCAHTOA. So what does that mean I'm going to use? I'm either going to use law of sines or law of cosines. That's how we handle triangles that are not right triangles. So when we have a triangle that's not a right triangle, doesn't have a 90-degree angle, and we need to find sides and angles, we use law of sines and law of cosines. That's what this chapter is all about. How do you handle triangles that don't have a 90-degree angle, don't have a right angle? Well, you use law of sines or cosines. If you have a right triangle, you use SOHCAHTOA. If you don't have a right triangle, you use law of sines or cosines. Okay, so which one? Well, I prefer to use law of sines. That one's easier. Remember? So I'll just write that up here. We use law of sines when? When can we use law of sines? We prefer that when we have side over opposite, or I should say the sine of the opposite angle, right? So like if I have, here I have a side, do I know the angle opposite it? No. No, if that 80 degrees is here, isn't it? That's that 80. So I don't really know this angle. I just know this whole thing here is 80, but I don't know this angle. So I have a side, but I don't know the opposite angle. Okay. I know this side. Do I know the opposite angle? No, don't know that. So I'm not going to be able to use law of sines on this one. Do you see that? Do you see how I know I can't use law of sines and I need to shift to law of cosines because I don't have a side and opposite angle pair. I know this side, but I don't know the opposite angle. I know this side, but I don't know the opposite angle. And I don't know this side at all or the opposite angle. So I can't use law of sines. So then I got to go into law of cosines. Okay, so how am I going to use law of cosines? Well, law of cosines is when you have, well, in fact, let me just go to it. Maybe that'd be the best thing to do. Let me go to law of cosines in the notes here real quick, if I can get there somewhat quick. Law of sines, law of cosines. There we go. Sure, bring it back over here. Okay. I can write on it. There we go. All right, so here we have law of cosines. And there's three versions. If you have a right triangle, do not use law of cosines, use SOHCAHTOA. Use law of cosines when you do not have a right triangle, and you also don't have a side and the angle across from it. If you have a side and the angle across from it, you should use law of sines, right? Specifically, use law of cosines to solve triangles when you are given, notice it says two sides of a triangle and the angle in between them, called side, angle, side. Is that what we have? Two sides and the angle in between. We have this side and this side. Do we know this angle in between? Well, yeah, not yet, but we can get it. Why? How do you, I mean you can get it? Well, we know this is 90 right here. Change my color. We know this is 90 right here. And so we like to get this entire angle. We know this part is 16, this part is 90. What's this part here? Can I get this little part right there? Yeah, I can. If I extend this side, see the trick we always do, just extend this like that, make it a right angle, and then see how this is 80 up here, and this is 90. Now I can find that. And once I find that, I'll have all three of these. I'll have the angle opposite the x. You see the trickery with angles? So what we're always doing is we're extending this side. So I make this little axis system, this little axis system, and then I extend them to meet to make a little right triangle. This is 80. I can find this, right? So let's do it. So this angle here must be what, 90 plus 80. I have those two angles. It's at 170. Then subtract that from 180. It's 10 degrees. So this must be 10 degrees, right? To make 180 in that right triangle. Every right triangle has, every triangle has 180. Okay, so what? Well, now I can get this entire angle here. Because it's what? 16 degrees plus 90 degrees plus 10 degrees. Right? Add those three up. What is that? It's 116 degrees. So I know that entire angle is 116 degrees. That's across. So now I have what they said down here. It said specifically, use law of cosines when you're given two sides of a triangle and the angle in between, called side, angle, side. Two sides and the angle in between. Do I have that? Yeah. Two sides, angle in between. I could do it. And it says, so how are we going to do that? So I'm going to use these formulas. And basically, notice they say you start with any of the three, doesn't matter. And it's the other squared. It's the other two sides squared minus 2 times those times the cosine of what? The opposite. B, A, C, C. See that? All right. So that's law of cosine. So here we go. I'm going to start with this guy. So x squared equals the other two sides squared. 7.2 squared plus 3.6, which doesn't matter what order, minus 2 times those two guys times the cosine of the 116-degree angle. Did you track with that? That's how law of cosines works, right? Any side squared is the other two side squareds minus 2 times those two sides times the cosine of the opposite angle. Remember, law of sines and cosines are always dealing with the opposite angle. See how that's dealing with the opposite angle? A, or B with B, or C with C. It's always the cosine of the opposite angle. And that's what I'm doing. So x squared, opposite angle, 116. So x squared is these other two squared minus 2 times m times cosine of the opposite angle. So then let's hit the buttons on our calculator. Grab my calculator. Make sure you're in degree mode because this is degrees. Double check your mode. Be a bummer to do all this good work and get it wrong because you're just in the wrong mode. But I've done that. So I'm getting 87.525516. Remember to use about 5 decimals always until you get to the very end. And then square root both sides to get the final answer. And I'm getting 9.3554. And then you can tell that's right. They just rounded it to 9.36. So there we go.